Okay. All right, so how to compute the perimeter or the distance around various shapes? Well, how about a square? A square is a quadrilateral where all the sides have the same length. And so if one side has a length of S units, then all the sides have lengths of S units. To find the perimeter of a square, we basically add together all the sides. So if you take a side S and add it to another length of S plus another length of S plus another length of S, we will have walked around the perimeter of this square. And so the total distance around this square is going to be S plus S plus S plus S, or 4 times S. So this is the formula to compute the perimeter of any square. You basically take 4 times the length of the side. All right, how would we compute the perimeter of a rectangle that has a length and a width? So if this side measures L units, then this side would also measure L units. If this side measures W units, then this side would measure W units. So to find the perimeter of a rectangle, the total distance around a rectangle, we would basically add the length to another length. That gives us 2 lengths, plus a width, plus another width. That gives us 2 widths. So we do have a formula for the perimeter of a rectangle. And computing such a thing is nothing more than adding twice the length of the rectangle to twice the width. That gives you the total distance around a rectangle. Perimeter of a triangle, tri means a 3-sided polygon. Okay, so all triangles have 3 sides. And the perimeter of a triangle is nothing more than the sum of all the lengths of the sides as you walk around the triangle. So if this side has a length of A units, this side has a length of C units, this side has a length of B units, walking around this triangle, we would take A plus B plus C. That would be the total perimeter of that triangle. Okay, so again, perimeter is just the total distance around a geometric shape. That's all it is. Any questions so far here? So these are some useful formulas for squares, rectangles, and triangles. Now, ladies and gentlemen, circles are special shapes. Circles basically have one side to them, a continuous side in the form of a curve. All right. Now, when we speak of the distance around walking around a circle, we speak in terms of the circumference of the circle. So the perimeter of a circle has a special name. It's called the circumference. Okay. All circles are characterized by a center point and also a diameter. The diameter of a circle is the length of the longest chord or line segment that can be put inside a circle that contains the center of the circle. If you take the diameter and divide it by 2, you generate the radius of a circle. So the radius of a circle is half the length of the diameter, or that's to say the diameter is 2 times the length of the radius. So how do we compute the circumference or the perimeter around a circle? Well, we have a special formula for that, ladies and gentlemen. The formula is right here. The circumference of a circle is equal to this funky looking character, which is called pi, times the diameter, or the circumference of a circle could be computed by multiplying 2 times that number, pi, times the radius. What is pi? Pi is an irrational number. It's approximately equivalent to about 3.14. All right, so we use about 3.14 as an approximation for pi's value. Wherever you see circles, pi is not far behind. Pi is associated with circles in the sense that to compute the value of pi, you always take the circumference, the total distance around a circle, and divide that by the diameter of the circle. So if you take the total distance around a circle and divide it by its diameter, you generate this number called pi, which is an irrational number. It's a decimal that rambles on and on and on, never terminating or never repeating. So we approximate it as about 3.14. Or as a fraction, we would approximate pi as 22/7, 22 sevens. Any questions so far, ladies? So we've seen some formulas as to how to compute perimeters around geometric shapes. We've seen the formulas for a square, a rectangle, and a triangle. And now we see the formula for a circle, which comes in two equivalent forms, pi times the diameter, or 2 times pi times the radius of the circle will give you the total distance around the circle. All right, any questions about those formulas there? All right, well, why not go down and start applying these to problems? So in section 8.1, we have our exercise set here. And you can see that we have many geometric shapes here that we are to compute the perimeter of. So let's start out relatively simple. Look at number 2. They give us a square, and this square measures 9 centimeters on each edge or each side. And so, ladies and gentlemen, what would be the perimeter of this square in problem number 2? What would be the total distance around that square? Anybody want to give that a shot? What would be the perimeter of that square? So each side has a length of 9 centimeters. So if we walk, we start here, let's say, and we walk clockwise around this square. So there's 9 centimeters plus another 9 centimeters plus another 9 centimeters. Back to where we started, plus another 9 centimeters. Now, repeated addition is performed more conveniently by multiplication. So 9 added to itself 4 times is better known as 4 times 9. And so what would be the perimeter of this square? It would be 36 what? 36 centimeters. That's the total distance around that square. Any questions how I computed the perimeter of that square? So that's the total distance around that square, 36 centimeters. All right. Let's try another one now. Notice perimeter units are linear units. Centimeters or just inches or meters or kilometers or miles or yards. Okay, just linear units. All right, how about number 4 here? They give us a rectangle. And they give us the dimensions of this rectangle. Usually the longer side is called the length. So the length of this rectangle we'll call 1 meter long. And the width is going to be 5/10 of a meter or 1/2 of a meter in length. And they want us to compute the perimeter of this rectangle. So, ladies and gentlemen, if this is a length of 1 meter, then this must be a length of 1 meter here, this side. And if this is a width of 1/2 meter, this must be also a width of 1/2 meter. So how do we find the perimeter? Well, it's going to be the length, which is 1 meter, plus a width of 0.5 meters, plus another length of 1 meter, plus another width of 0.5 meters. So adding all these together, now an easier way to do this, to compute this, is to use the formula 2 times the length plus 2 times the width. Since you're adding 2 lengths together and 2 widths together, this is more convenient, more compact way of computing the perimeter of a rectangle. So the perimeter of this rectangle is going to be 2 times the length, which is 1 meter, plus 2 times the width, which is 0.5 meters. Or if you just want to add all these together, that would still work also. So it looks like our perimeter is going to be 2 meters, plus 2 times 1/2 meter is 1 meter. Total perimeter is going to be 3 meters. And that's the total distance around that rectangle, 3 meters. Any questions how we computed the perimeter of that rectangle? All right. Number 6 appears to be cut off. We don't know the length of that side there. We'll have to try number 5. What would be the perimeter of this triangle in problem number 5? Well, the perimeter of a geometric shape is the total distance around the shape. And so therefore they give us the lengths of all three sides of this triangle, and they want us to compute the perimeter. And so therefore, if we walk around this triangle, how many inches will we have walked around? We walk from here to here, that's 10 inches. Plus we walk from here to here, that's 12 inches. Plus we walk here back to where we started, that's 14 more inches. So it turns out the perimeter of this triangle is going to be 36 inches. Do you agree? That's the perimeter. Any questions on how we're computing the perimeter of geometric shapes, total distance around? All right. Now, some shapes are not going to be, well, let's look at this shape here. Does anybody know what this shape is called? Number 8. It's not a triangle. It's not a circle. It's not a square. It's not a rectangle. Anybody ever see a shape like that and know the name of that shape at number 8? The name of that shape starts with the letter T, as in Tom. Anybody know what that shape is called? This shape, ladies and gentlemen, is called a trapezoid. Not a trampoline. I didn't say trampoline, I said trapezoid. So problem number 8, we have a trapezoid here. One side measures 7 3/5 inches. The other side measures 4 inches. 5 1/5 inches for the other side. And 13 inches for the other side. So what would be the perimeter of this trapezoid? Well, it's going to be the total distance around this trapezoid. And ladies and gentlemen, what is the total distance around this trapezoid? Well, you start here and walk from here to here. You walk 7 3/5 inches. Plus here to here is 4 inches. Plus here to here is 5 1/5 inches. Plus here to here is 13 inches. So how do we find the perimeter? Well, we can add all these up here, and feel free to, you can use your calculator to add these up. So let's go get our calculator and see if it's working this morning. All right. So we clear our screen and we add all these dimensions together, 7 3/5. We go get our mixed number template, 7 3/5. That's going to get added to 4 inches plus 5 1/5 inches. Plus 13 inches. And there we go, ladies and gentlemen. We would have the total distance around that trapezoid. That's the perimeter. We should turn that back into a mixed number so we can better appreciate what it's saying. So 2nd times 10 to the nth power button takes us back to a mixed number. So 29 4/5 inches would be the total distance around that trapezoid. That would be its perimeter. Any questions how we computed that? So 29 4/5 inches would be the perimeter of that trapezoid. All right, now some shapes, ladies and gentlemen, are not going to be, how shall I say it? Not exactly your run-of-the-mill shapes. So problem number 10 here, they give you what kind of looks like maybe the shape of like some sort of a floor plan of a house or something. Well, anyways, they want us to compute the perimeter of this geometric shape. which really does not have a name, collectively speaking. We can't call it a rectangle, can't call it a triangle or a trapezoid or, you know, a square. But nonetheless, we should be able to compute the total distance as we were, if we were to walk around this. So envision this as being like a building, and we're going to walk the lengths of all the sides, one complete trip around this shape here. That will be the perimeter. And so as I'm here to here is 30 inches. Anybody know what this length would be right here? This length right here. The left side length. Anybody know what this would be?
12 inches? Because it's the same size as the other one.
Yeah, 12 inches, because it's the same as this over here. You are correct.
Yes.
That would be 12 inches there. All right. Now, so I'm going to try to sketch this picture on my paper for illustrative purposes here. We have to understand what is clearly given to us and what it is we need to find. So we know this is 30 inches. We know this is 12 inches. We know this is 8 inches. We don't know that. We know this is 10 inches. And we know this is 8 inches here. Okay, to find the perimeter of this shape, ladies and gentlemen, we know this length here. We know this length here. We know this length here. We don't know this length. We know this length here is 10 inches. We know this is 8 inches. We don't know this length, and we don't know this length. 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 All right, what do you think this length would be here? Right here, this length.
8 inches.
Be the same as this probably, correct? 8 inches here, so probably what, 8 inches here. So therefore we'll call that 8 inches. Now, somebody indicated that this length would be 12 inches because this is 12 inches, and you are correct. This would be 12 inches. Here's a tougher question. What would be the length of this right here, this length? What is this length? Well,
8 inches?
okay. Now we better check and see if it's 8 inches here. Check this out. We know from here to here is what, 30 inches, correct? 30. Watch this. Ladies and gentlemen, sometimes we draw what are called construction lines to help us, better understand the situation. So feel free to draw some dashed construction lines. It's perfectly okay to do that. No harm done. Those are called construction lines. Kind of square your picture off here. Now, do you agree that if this is 10 inches, this must be what? This must be 10 inches, correct? And if this is 8 inches, this must be what? 8 inches. Do we buy that so far? But ladies and gentlemen, we know here to here is 30 inches. So what would be this length here? Well, do you agree it's going to be 30 inches, subtract 8 inches, and subtract 10 inches? Do you agree? If I take 30 inches and subtract off 8 inches, subtract off 10 inches, that leaves me with this length, which would then be this length. So what is 30 minus 10 plus 8 is 18. What is 30 minus 18? 30 inches minus 18 inches.
12.
12 inches. So if this is 12 inches, this must be 12 inches up here. Now we know all the sides. So now we can compute the perimeter of this shape. So let's walk around this shape, and it doesn't matter where you start and what direction you walk, clockwise or counterclockwise, doesn't matter. I'm just going to pick, I'm going to go right here, start right here, and I'm going to walk clockwise. So here to here is 30 inches. Plus I walk from here to here, that's 12 more inches. Plus I walk from here, that's another 12 inches. Plus I walk from here to here, that's 8 inches. Plus I walk from here to here, that's 10 inches. Plus I walk here to here, that's another 8 inches. Plus I walk here to here, that's another 8 inches. plus I walk from here to back to where I started, 12 inches. There you go. That would be the perimeter of this geometric shape. Got to add all these together. Oh, what's this? 42 plus 12 is 54 plus 8 is what's 54 plus 8? 62 plus 10 is 72 plus 8 is 80. 88. What's 88 plus 12?
100.
100 inches. That's the perimeter of that weird looking shape, geometric shape. That's the total distance around. Everybody understand how I computed that by building these little construction lines to help us deduce what this length had to be. Okay. You can always build construction lines into a picture. Always use dashed lines though. Very important so that we know they're construction lines. All right. Any questions on that, ladies? 100 inches total distance around that geometric shape. That's the perimeter. Notice we don't have a nifty little formula to compute the perimeter of this type of shape because it's not, you're running a mill shape. It's not like your square or your rectangle or, it's a weird looking shape. It's a conglomeration of what looks like a whole bunch of little rectangles. Do you agree? All right. So that one's done. That was number 10. And let's see where we are with the old clock here. All right, maybe we could try another one here. Number 12, they want us to compute the perimeter if we were to walk around this entire shape. So if we were to hug the wall and walk all the lengths of the walls all the way around, we would have walked the perimeter of that shape. Do we know all the side links? Are they all given to us or are we going to have to find some? What do you think? Going to have to find a couple or are we good here? Something tells me we may have to deduce a couple of these side links, correct? I don't think we're given all these side links. So I'm going to try to sketch this picture on my paper so that I can illustrate how we're going to go about finding all these side links here. And obviously it does take a little time to sketch the picture accurately. So we have to have a little bit of patience on these problems. All right, I think I got everything labeled. All right, we want to find the perimeter of this geometric shape, which is a weird looking shape. We want to, try to find all these side links here. Now, do we know, let's see, what are we missing here? Well, we see, we got that. We don't know this side length. We don't know this side length here. They do not tell us that. But ladies, watch this with some construction lines, we can deduce it. I'm going to draw a little construction line going this way. I'm going to draw a little construction line going this way. Okay. Now, do you agree if this is 15 feet, this must be what? 15 feet. Here to here is 15 feet. If this is 10 feet, this must be 10 feet here to here. 10 feet. If this is 25 feet here to here, this must be 25 feet here to here. 25 feet. Everybody see that there? All right, what's the length of this side here? Anybody? What's the length of this side? Well, here to here is 50 feet. I'll bet dollars to donuts that this is 50 feet. What's this length here to here? What do you think? We need this length. Kind of looks like this might be what? 30 feet. I think we got all our lengths. Now we can just walk around this thing and compute the perimeter. All right, doesn't matter where you start. Just got to walk around here. I'm going to start here. I'm going to walk this way. So here to here is 50 feet. Plus, and then I'm going to walk from this corner all the way up to here. That's going to be 15 feet plus 10 feet is 25 feet plus another 25 feet is 50 feet. Plus here to here is 50 feet. Plus here to here is 25 feet. Plus here to here is 30 feet. Plus here to here is 10 feet. Plus here to here is 30 feet. Plus here to here is 15 feet. There you go. Now we just add all these together and we have the perimeter of this shape. There's 50 plus 50 is 100 plus 50 is 150 plus 25 is 175. 175 plus 25 is 200 plus another 5 is 205 plus 10 is 215. 215 plus 30 is 245. 245 plus another 15 is going to be what? 260? 260 feet, ladies and gentlemen, would be the perimeter, the total distance around that shape. Any questions how we deduce that? Computer go. And that's the perimeter, 260 feet around. So again, construction lines save the day. Okay. All right. Any question about those? Okay, ladies and gentlemen, let's go down to this circle problem here. Number 16. They want us to find the circumference of each of these circles here. So problem number 16, they give us a circle. Do they give us the diameter or the radius of this circle? Diameter or radius? What do you think? Lydia, what do you think that is? The diameter or the radius, that 2 inches? What's that?
I was thinking the diameter.
Well,
I'm not sure.
the diameter,
The radius.
yeah, that would be just a radius there, so 2 inches. So the length of a line segment from the center to a point on the circle is called the radius, and that's 2 inches. So what would be the diameter? What would be the diameter if they wanted the diameter here? If this is 2 inches, a diameter is adding another what? Radius. Do you agree?
Mm-hmm.
So what will be the length of the diameter? If this is 2 inches and this is what, 2 inches?
It'd be 4.
The length of the diameter would be 4, correct? 2 inches plus 2 inches or 4 inches. So the diameter is 4 inches. That's to say the radius is half the diameter. So that's to say the radius is 4 inches divided by 2 or 2 inches. Or that's to say the diameter is 2 times the radius, correct? All right, anyways, to compute the distance around this circle, the circumference of this circle, which is called the perimeter of a circle, we need to use a formula. And does anybody remember what that formula was? Circumference. You can use one or two formulas here. It's up to you. You can use the one that just involves the diameter, in which case the circumference is pi times the diameter. Or, ladies and gentlemen, if you want to use the radius, you can use this alternative equivalent formula for the circumference, which is to say 2 times that irrational number pi times the radius. These are equivalent formulas because you can see it. 2 times a radius is what? A diameter. So you can replace 2r with d. All right, if we use the diameter, our circumference in exact form will be pi times the diameter. The diameter is 4 inches. So in exact form, the circumference would be 4 pi inches. We say this answer is left in what's called exact form in terms of pi. If you want to approximate the circumference, you would have to replace pi with its decimal approximation. Pi is an irrational number. It is approximately equivalent to 3.14. But in reality, pi's decimal goes on and on and on forever and ever, never terminating or never repeating. I think a supercomputer in Japan, I think, took pi out to like 20 trillion decimal places, and it still did not show any signs of repeating or terminating. Safe to say it's probably irrational. So, ladies and gentlemen, what is 4 times 3.14 as we approximate this circumference? It's going to be 12.56 inches. This is approximately the distance around that circle, not exactly, approximately. The exact distance around is 4 pi inches. This is called the approximate circumference or distance around. If you chose to use this formula, it would still work. The circumference would be 2 times pi times the radius being 2 inches. But what's 2 times 2? That's 4. So again, we get 4 pi inches, the exact circumference of the circle. Or, ladies and gentlemen, an approximation would be 2 times 3.14 times 2 inches. And again, you would get, if you work this out on your calculator, 12.56 inches as an approximation of the circumference. So again, it does not matter which formula you use, whether you use this formula, you want to use the diameter, or you use this formula, you want to use the radius. Any questions how we computed the circumference of that circle, the distance around that circle? Now look at this shape here. Number 14, ladies and gentlemen, this is a weird looking shape. They want us to compute the circumference or the perimeter, the total distance around this shape here. So if you were to walk here to here, you walk 5 miles. If you walk here to here, or actually drive, I would think we'd drive in our car. If you drive in your vehicle here to here, you've driven 5 miles, drive here to here, that's 6 miles. But if you drive around this half circle, ladies and gentlemen, what distance do we carve out in miles from here to here? Oh, they don't give us that distance. We're going to have to find it. And then we drive from here to here. How many miles would I drive from here to here? Anybody? From here to here. How many miles?
Six.
6 miles, because this is 6. So the only length we're missing is the length of this what? This semicircle circumference. Do you agree? We need the circumference of this semicircle, this half circle here. How are we going to find that circumference, that distance around that curve? Well, we're going to have to use our formula for circumference because that really is a semicircle or half a circle. And so let me draw this picture in entirety on my paper. I'll try to sketch it. Just bear with me if you could. They tell us this is 3 miles here. This is 5 miles. This is 6 miles. And so therefore this would be 6 miles. And we have to find, ladies and gentlemen, we have to find the length of that curve here. We got to find the distance around this semicircle's circumference here. Got a question for you. If I was to continue this picture over here, I would what? Carve out a complete circle. Do you agree? Do we all buy that? Complete circle? Now, what's the diameter of this circle? What would be this diameter? Anybody? What's the diameter of this circle here to here, this length? Well, looks like it would be what? Would it be 5 miles? Or would it be 4 miles?
4.
4 miles. Here to here is the same as here to here, 4 miles. So this diameter here of what would be a circle would be 4 miles. So we know the diameter of our circle is 4 miles. Whoops, 4 miles. We want to find the circumference of not the entire circle, not the entire circle, but just half the distance around the circle. We just want the circumference of this semicircle, we say. So we know the circumference formula for an entire circle is pi times the diameter of the circle. But ladies and gentlemen, we just want the length or the circumference of half our circle. So we're going to have to take our circumference and divide it by 2, which means we're going to have to divide pi times the diameter of that circle by 2. So therefore, the exact distance around this semicircle would be pi times the diameter, which is 4 miles, divided by 2. So the exact distance from here to here around this semicircle would be 2 divided into 4 2 times. We can reduce. So 2 pi miles exactly. This is leaving the circumference of the semicircle in exact form. If you want an approximation, you would replace pi with 3.14. And so 2 times 3.14 would give us about 6.28 miles as an approximate circumference of this semicircle. So ladies and gentlemen, here we go. The perimeter completely around this entire geometric shape is going to be what? I'm going to start up here and walk around it this way. So here to here is 6 miles. Plus here to here, around this semicircle circumference, we computed was about 6.28 miles. Plus here to here is 6 more miles. Plus here to here is 3 more miles. Plus here to here is 5 miles, and I've gotten back to my starting point. All we gotta do is add all this together, and we have the total distance around this weird looking shape. 6 plus 6 is 12, plus 3 is 15, plus 5 is 20. What's 20 plus 6.28? 26.28. Ladies and gentlemen, you have the circumference of that weird looking shape. 26.28 miles completely around that shape. Walking from here to here, all the way around, back to here. 26.28 miles. You'd probably definitely want to drive a car. Do you agree? Any questions how we piece that one together? All right. Hey, I got a question for you, ladies and gentlemen. What's the circumference of our planet? As you all know, if you don't know, you're about to find out. Our planet is roughly in the form of a sphere, like a ball. We all live on a ball. Isn't that kind of comical when you think about it? Anyways, ladies and gentlemen, what would be the total distance around our Earth here? What's the circumference of our Earth? If you were to take a hot air balloon and go all the way around the Earth, and I think somebody actually did that, didn't they? I forget the year they did that, but they took a hot air balloon all around, one trip around the entire Earth. What would be the total circumference in miles that you would go if you make one trip around our planet here? Well, we need to know the diameter or the radius of the Earth, ladies and gentlemen, and I am going to tell you what that is. The approximate radius of our Earth is, are you ready for this? It's a little greater than 20 miles. The radius of our Earth is about 4,000 miles. So therefore, the diameter of our Earth would be what? What would be the diameter of our Earth? If the radius is 4,000 miles, what's the diameter? How many miles is the diameter? If the radius of our Earth is 4,000 miles, what do you think our diameter would be of our planet? So the diameter is twice the radius, which would be 2 times 4,000 or 8,000 miles. So the diameter of our Earth is 8,000 miles, approximately. So to find the circumference of our Earth, I'm going to use the formula that says pi times the diameter. So the exact circumference or distance around our planet, totally around, would be equal to 8,000 times pi miles. So ladies and gentlemen, the approximate circumference of our Earth would be 8,000 times 3.14 miles, which is to say approximately what? How many miles around the Earth? Well, I'm getting about 25,120 miles. That would be the number of miles that you would have to take a hot air balloon around our planet to navigate one circumference of our planet. About 25,100 miles, 120 miles. Pretty far, isn't it? How far is it from here to Los Angeles? Anybody? Well, let me ask my phone. I can't find my phone. Anybody ask their phone how many miles it is from, let's say, Detroit to Los Angeles? Anybody? Distance between Detroit and Los Angeles. Anybody got a phone up there? Can I ask it?
2,281 miles by car.
Okay, 2,200. All right, so I'll tell you what, let's take this 25,120 and divide it by 2,280. How many trips to Los Angeles would that be if we went around the Earth one time? Take 25,120 divided by, you said 2,280 about? Wow. Ladies and gentlemen, to go around our planet just once would be equivalent to about approximately 11 trips. 11 trips to Los Angeles. 11 trips. Or that would be 5.5 what round trips. Do you agree? 5.5 round trips. Detroit to Los Angeles and back to Detroit. 5.5 of those. That would wear me out. I don't know about you. Would you want to drive all that? I would have to stay at a motel at least one night. Yeah, right. Okay, so we got a pretty big planet, ladies and gentlemen. Circumference is quite big. All right, classwork number 1, ladies and gentlemen. I want you to try a problem for me if you could. All right, what I want you to do is I want you to do problem number 13. I want you to compute the perimeter of this shape here, problem 13. And they want you to approximate pi's value at 3.14. Problem number 13, classwork number 1. Compute the perimeter of this shape. Go ahead and do that.
We can't hear you.
All right, so anyways, walking here to here is 4 inches, and the semicircle circumference would be half the circumference of an entire circle. If you were to continue this around, you'd have an entire circle. So we got to divide this by 2. So that would be about 6.28 inches. So this distance around here is about 6.28 inches. Plus another 4 inches, plus another 4 inches. Okay. And so what does that net us? Well, that's going to be about 18.28. Anybody get that? That would be the circumference of that, excuse me, the perimeter of that geometric shape there. Okay. Anybody get that correct? All right. It's about 18.28 inches. So that section there, 8.1, talked about perimeter. Well, perimeter is the total distance around a geometric shape, ladies and gentlemen. Any questions about 8.1? All right, let's go to 8.2. 8.2 is involving what is called the area of a geometric shape, a two-dimensional shape, area. And area, ladies and gentlemen, is the amount of fill that lies within the borders of the geometric shape. Suppose we have a rectangle here that measures 4 centimeters by 2 centimeters. So the length is like 4 centimeters, the width is like 2 centimeters. If I take this 4 centimeters and partition it up into 4 equal size lengths here, here to here is 1 centimeter, another 1 centimeter, another 1 centimeter, and another 1 centimeter. And if I take this 2 centimeter length and partition it up into 1 centimeter equal lengths, so here to here is 1 centimeter, and here to here is another 1 centimeter. How many little squares do you count now after partitioning this rectangular diagram up? Each one of these little squares represents what's called 1 square centimeter of area. 1 square centimeter. So how many square centimeters do we see as being the area of this rectangle that measures 4 centimeters by 2 centimeters? What do we see? How many do we count? 1, 2, 3, 4, 5, 6, 7, 8. So it looks like the area of this rectangle would be 8 square centimeters. Now, this is one way to take a rectangle and determine the area of it by partitioning it up into so many 1 square centimeter or 1 square unit little squares. But ladies and gentlemen, there's got to be an easier way because this could take some time, especially on large rectangles. So the easier way is to memorize a formula for computing the area of a rectangle. It's nothing more than the length times the width. So if you take 4 centimeters and multiply it by 2 centimeters, you get the total area of that rectangle as being 8 square centimeters. 8 square centimeters would be the area of that entire rectangle. Does that make sense? So we're discovering very quickly here that area units are different than perimeter units. Perimeter units are linear units, centimeters, meters, feet, yards, miles, kilometers. But area are square units, square centimeters, square inches, square yards, square miles, square kilometers, square meters, okay? Area must always have square units. All right, so here are some formulas for computing areas of geometric shapes. These are not perimeter formulas, these are area formulas. Perimeter is just the total distance around a shape, but area is the amount of fill that is contained within the borders of the shape. So the area of a square is nothing more than the product of its 2 sides. Side times side will give you this area of a square, and the units will be square units. The area of a rectangle is nothing more than taking the length and multiplying it by the width. Length times width gives you the area of a rectangle. This is called a parallelogram. It is a quadrilateral. It has 4 sides, just like a rectangle and a square. But a parallelogram is different than a rectangle or a square in the sense that its sides do not form right angles with each other. With a square, you have 4 90-degree angles. With a rectangle, you have 4 right angles or 4 90-degree angles. With a parallelogram, these angles are no longer 90 degrees here. Okay. But how would you find the area of a parallelogram? Well, ladies and gentlemen, you would take the length of the base of a parallelogram and you would multiply it by the altitude or the height of the parallelogram. And the altitude or the height of the parallelogram is found by taking a line and dropping it perpendicularly down to one of the sides of the parallelogram. And the side that that height is dropped down towards is called the base of the parallelogram. Notice the height makes a 90-degree angle with the base, or we say the height or the altitude is perpendicular to the base of this parallelogram. To find the area of a parallelogram, it's just a simple matter of multiplying the length of the base times the length of the height. Base times height gives you the area of a parallelogram. Any questions about any of these formulas here so far? How do you find the area of a triangle? Well, just like a parallelogram, a triangle is characterized by a base and also a height or an altitude. So to find the area of a triangle, it's really going to be 1/2 the area of a parallelogram. So to find the area of this triangle, we would take 1/2 times the length of the base of the triangle times the length of the height of the triangle. That would be the area of the triangle, 1/2 times the base times the height. A circle is a special situation, ladies and gentlemen, always is. And wherever you see a circle, not far behind is that irrational number pi. So the area of a circle is found by taking pi times the radius of a circle times the radius of a circle. Or it's found by taking pi times the square of the radius. So the area of a circle can be computed by taking pi times the radius. Pi r squared gives you the area of a circle. Any questions about any of these formulas for these geometric shapes here? All right, so let's see if we can get into computing the area of some of these problems here. Let's go right down to the practice set, 8.2. And let's see if we can tap into a couple of these problems here. Wow, these are messed up here. I'm just curious, does anybody have a textbook handy? Problem number 2 here. It looks like the diagram got cut off and the dimensions are at the bottom here or something. They got meshed up with this parallelogram down here. It's a real mess.
In the book, it's messed up too.
It's messed up in the book too. Unbelievable. Yeah. You can see, this is all messed up. Like if you look at number 1 here, we can't see the dimensions of the square. We don't know what the length of the side is. They don't give you that anywhere. I don't see it. All right, well, we just can't do that problem. That's all there is to it. Let's just say for problem number 1 that the length of the side was 10 feet. What would be the area of that square? If the length of a side of a square is 10 feet, what would be the area of that square? How do we find the area of a square? We take what? Side times what? Side times side? So the area of this square would be 10 feet times 10 feet. And that's known as 100, not feet, but what kind of feet? Not just feet. What's feet times feet? Square feet. Got to have the proper units, ladies and gentlemen. We're talking about area now. So this will be 100 square feet of area contained within the borders of that square. Okay. If it measured 10 feet on the side, 100 square feet. All right, number 4, what would be the area of this rectangle? How do you find the area of a rectangle? We have a rectangle that measures, has a length of 2 inches and has a width of 0.5 inches. So what would be the area of this rectangle here? Well, area of a rectangle is equal to the length times the width. So it'll be 2 2/10 of an inch multiplied by 5/10 of an inch, or a 1/2 inch. And what's a 1/2 inch times 2.2? Should give you 1 1/10 inches what? Squared. Inches times inches is square inches. Okay? That would be the area of that rectangle. This is pronounced as square inches. Square inches. Okay. So that would be the area of that rectangle. Everybody understand how we did that? All right, let's see, that's messed up. Number 6, they give us a parallelogram here, and they want us to compute the area of this parallelogram. And so we know this side measures 8 feet here. And they tell us the height of this parallelogram is what? Is 6 feet. And so how do we find the area or compute the area of a parallelogram? Area is equal to the base times the height. The base would be 8 feet. How do I know this is a base? Because it is perpendicular to the height. You see that there? So the base would be 8 feet times the height, which is 6 feet. Ladies and gentlemen, we're looking at 48 square feet for the area of this parallelogram, 48 square feet. Is this making sense how we're computing areas of geometric shapes here so far? And then they give you some diagrams here where, you know, they're not your normal shapes. So problem number 8 here, they want you to compute the area of this, what looks like maybe like a floor plan of like a house or something. I don't know. And how are we going to do that? Because we don't have a nice area formula like we do for a rectangle or a square. We don't have any of that because this is not a rectangle or a square, the shape. In fact, you can't call it any name. It's just some sort of a shape. It just looks like it's kind of like the collection of shapes, okay? So how are we going to compute the area of this entire shape here? Well, what we can use are called construction lines, ladies and gentlemen, to basically cordon this off into shapes that we do know how to compute areas for. And it doesn't matter how you draw these construction lines, you know, it's really up to you. Be my guest. But I'm going to drop a construction line down here, perpendicular down here. I'm going to drop a perpendicular construction line down to this side here. And ladies and gentlemen, I can see how many rectangles can we see in this picture? We got 3 different rectangles. Rectangle number 1, 2, and 3. So if I can find the area of all 3 of these rectangles and then add them together, I'll have the area of the entire shape. Uh-oh. But ladies and gentlemen, how do we find the area of rectangle number 1? Area of rectangle number 1. Roman numeral 1. Area of a rectangle is length times width. We know the width is 5 feet, but we don't know the length. What do you think this length would be here? Here to here.
8.
8 feet.
Yeah, we got 8 feet over here. So I'll bet that looks like 8 feet here. Hence, we can say 8 feet multiplied by 5 feet. And hence the area of rectangle number 1 would be 40 square feet. We found the area of that first rectangle, and now we'll have to find the area of rectangle number 2. Rectangle number 2 measures how? Oh, I'm not sure. I know that here to here is 15 feet. But ladies and gentlemen, look at this. I know we can deduce this. I know here to here is what, 5 feet? Because we got 5 feet up here. And I know here to here, this is 5 feet. This must also be another what, 5 feet. So what do you think this length has to be here? It has to be 15 feet minus 5 feet minus 5 feet, or minus 10 total feet would give me what? Also 5 feet right in here. That would be 5 feet. Uh-oh, but we don't know this dimension here to here. We know this is 5 feet. We deduced that because 15 feet minus 5 feet leaves us with 5 feet. Well, what would be this length here? Well,
4 feet.
Yeah, 4 feet. And how did you get this? Well, we know this is 8 feet. See, look, you could draw another construction line if you wanted to. You could put another little construction line going horizontal. Perfectly okay to do that. You see, if here to here is 8 feet and this is 4 feet, if you take 8 feet minus 4 feet, that leaves you with this, which is 4 feet. You are correct. 4 feet. So the area of rectangle 2 is going to be 5 feet, 5 feet times 4 feet. And that's going to net us 20 square feet. Finally, the area of rectangle number 3, whose dimensions would be what? 8 feet by what? 5 feet. So it's going to be 8 feet times 5 feet, or 5 feet times 8 feet. That gives you 40 square feet. Finally, to get the total area, we know that's going to be the sum of area 1, 2, and 3, all areas added up. So the total area of that shape is going to be area 1, which is 40 square feet, added to area 2, which is 20 square feet, added to area 3, which is 40 square feet. And that gives us 100 square feet total. And we're done with the problem. So the entire area of this entire shape, ladies and gentlemen, is 100 square feet. Everybody understand how we deduced that? 100 square feet. We kind of did it in stages. All right. 100 square feet. All right, how would I find the area of like this circle that has, is that a radius or a diameter? Lydia, what do you think that is? Radius or diameter? 2 inches.
I think would be radius.
All right, radius. You redeemed yourself.
Yes, I did.
Okay, so that's a radius, ladies and gentlemen. So that's the radius, which is 2 inches. And how are we going to find the area of this circle? The area. Well, we're going to have to use a what? A formula. Do you remember the formula is for the area of a circle? What was that again? It was pi times what? Radius squared?
Mm-hmm.
Pi times radius squared. So this is saying pi times radius times radius. So the area of the circle is going to be pi times the radius, which is 2 inches, times the radius, which is 2 inches. So the area in exact form, 2 inches times 2 inches times pi will be 4 pi square inches. Don't forget to put square inches. Inches times inches is square inches. We're leaving if we leave our answer this way, we're leaving it in what's called exact form in terms of pi. If you get on your calculator and approximate pi's value to be about 3.14, then we can get an approximate area, which is 4 times 3.14 square inches, which would be what, 12.56, I believe, 12.56 square inches. That's the approximate area, ladies and gentlemen, of that circle. Do we understand how I computed either the exact area or the approximate area? Wavy equal signs means approximately equal to, not exactly. Okay. All right, we good on that one? Area of a circle. Notice to find the area of the circle, you need to know its radius. We could, derive a formula if you knew the diameter. But ladies and gentlemen, if I give you the diameter of the circle, we would just have to do what to the diameter? Just divide it by what? 2 to get the radius. And then we could incorporate it into this area formula. All right, done with that one. Oh no, say it isn't so. There's this picture again, ladies and gentlemen, but this time they don't want us to compute the perimeter. They want us to compute the area. How are we going to find the area of this entire shape, number 14? Anybody have an idea as how we're going to attack this in general? Let me ask you this. How many different shapes do you see in this overall picture, this overall shape? Can anybody name the different shapes we see in this overall picture here?
There's 3 or 2.
Well, no, you're right. There's 3 different shapes. Yeah, there are 3 different shapes that this entire picture is comprised of. I see a what? I see a
Triangle, a rectangle, and a half circle.
that's exactly what I'm seeing here. I see a triangle, I see a rectangle, and I see a semicircle here, okay? So you know what? That's exactly how we're going to compute the area of this entire shape. We're going to have to do it in stages. We're going to have to find the area of this triangle. We're going to have to find the area of the rectangle. And we're going to have to find the area of this semicircle. And then we'll add all these areas together and we'll be done. I think I'm missing some dimensions here. Hold on a second. This is 2 miles. They tell us this is 2 miles here. They tell us this is here 6 miles here to here. And that's it. Oh, they tell us this height, which is 4 miles. This height, this 4 miles is not only a height or an altitude for this triangle, but it's also the length of the side of our rectangle. Notice that. That is shared by both figures. All right, so ladies and gentlemen, how do I find the area of a triangle? Do you remember the formula? Because it really does come down to a formula. It's 1/2 times the base times the height. So what's the base of this triangle? Well, if we call this the height, this would be the base, 2 miles. So the area of that triangle is going to be 1/2 times its base, which is 2 miles here to here, times the height or the altitude, which is 4 miles here to here. This is the height of this triangle here. So what's 1/2 of 2? That's 1, and 1 times 4 is 4. So we would get 4 square what? 4 square miles is the area of this triangle, 4 square miles. Now we'll find the area of the rectangle. To find the area of the rectangle, we know here to here is 6 miles, and we know here to here is what? 4 miles. So to find the area of the rectangle, we take the length times the width. So it's going to be 6 miles multiplied by 4 miles. And that gives us 24 square miles for the area of the rectangle. Finally, we got to find the area of this semicircle. If this was a complete circle, ladies and gentlemen, if it was, what would be the diameter of this circle? Can we read off the diameter of this circle here to here?
It'll be 4.
4, because here to here is 4, right?
Mhm.
4 miles here, 4 miles here. So we know the diameter of our circle is 4 miles. But to compute the area of this circle, we don't want the diameter, we want the radius. So what do I do to the diameter to get the radius? Anybody remember?
Divide by 2.
Take the diameter divided by 2. So that means the radius is going to be 4 miles divided by 2. The radius will be 2 miles, correct? But ladies and gentlemen, how do we find the area of a circle? In general, we have a formula. Area of a circle is always pi times the what? A radius squared. Do you agree?
Mm-hmm.
But we don't want the area of the entire circle, because part of the area of this circle is part of the area of the rectangle we already computed. We just want the area of this, the semicircle out here. So to find that, we're going to have to take our area of the entire circle and divide it by 2. That'll give us the area of the semicircle. So it's going to be pi times the radius squared divided by 2, which is to say pi times the radius, which is 2 miles, times 2 miles divided by 2. Heck, this 2 drops out with one of these 2's here, and we're left with just 2 pi miles squared, 2 pi square miles, excuse me. Now, if we want to approximate this, replacing pi with 3.14, we would get approximately about 6.28 square miles. That would be the area, the approximate area of that semicircle. And so, ladies and gentlemen, what do you think the total area of this shape is going to be? It's going to be the sum of the areas, correct? Got to add all the areas up. And so the total area is going to be what? 4 square miles plus 24 square miles plus, what was that? 6.28 square miles? Four plus 4 is 8. 8 plus 6.28 is going to be 14.28. So 14.28 square miles is the area of the entire shape, correct? 14.28 square miles. You understand how we broke that up into 3 different areas: triangular area, rectangular, and semicircle area, and added them all together. So you can see the calculations do take a little bit of time. There's no doubt about it. So we have to exercise a little bit of, patience. So. Okay. Okay, so let's see. Even if it means that we're not going to have a classwork for this section in particular, I might roll it into one last classwork for the next section. I want to do one like number 22. It says a garden is rectangular with a width of 8 feet and a length of 12 feet. So I'm going to draw a rectangular garden that has a length of 12 feet and has a width of what, 8 feet, I believe. Now it says it is surrounded by a walkway that's 2 feet wide. How many square feet of the area does the walkway cover? So think about this, ladies and gentlemen. You got a garden, but you have a walkway that's 2 feet wide around this garden. 2 feet wide. Think of it this way. How many square feet of gravel would we need in order to put gravel on the sidewalk around our garden? Because they sell it usually by the square foot or the square yard at like retail outlet. So if I wanted to put gravel on the sidewalk around my garden, the garden is right in the middle here. How many square feet of gravel would I need? Well, this is a darn good question here. How are we going to do that? Well, we know that the width of our sidewalk is 2 feet. They tell us 2 feet here, and this is also 2 feet here. 2 feet, 2 feet. And it's also true that here to here is 2 feet. That's also true. Here to here is 2 feet. So I'm looking at this. I think we could deduce this here. Here to here is 2 feet, correct? So if my garden is 12 feet, what would be the length of this big rectangle? What would be the length of this entire big rectangle if my garden has a length of 12 feet? 12 feet here to here. I want the length of the big rectangle. Would I not take 12 feet and add to that 2 feet plus another what? 2 feet. Isn't that true? To get this entire length here? So what is 12 feet plus 2 feet plus 2 more feet? gives me 16 feet for the length of the big rectangle. What would be the length, what would be the width of the big rectangle here to here? Well, we know here to here is 8 feet. Do you agree if I take 8 feet and add 2 more feet this way and then 2 more feet this way, I'll have the big width? What's 8 feet plus 2 feet plus 2 feet? 12 feet. Now, here's how we're going to find the area of the sidewalk. Do you agree, ladies and gentlemen, if I take the area of the big rectangle and subtract off the area of the small rectangle, which is the garden, do you agree that would leave me with the area of the surrounding sidewalk? Does that seem reasonable? If I take the area of the big rectangle, ladies and gentlemen, and if I cut out the area of the smaller inner rectangle, which is the garden, do you agree that would leave me with the area of the surrounding sidewalk? Is that true? That's how we're going to do this. How do we find the area of the big rectangle? We take its length times its width. So it's going to be 16 feet times 12 feet. Then we're going to subtract off the area of the garden, which measures 12 feet by 8 feet. Now, what's 16 times 12? That's not a number I have in my back pocket. 192. So 192 square feet is the area of the big rectangle, minus the area of the garden is going to be 96 square feet. So the area of the sidewalk is going to be 192 minus 96, or 96 square feet. Now, ladies and gentlemen, we know exactly how many square feet of gravel to buy so that we can put gravel in the surrounding area of our sidewalk. Do you agree? Everybody see that there? That was a good problem, wasn't it? That would be 96 square feet for the area of the sidewalk. All right. Let's see if we could try one of these here. Number 28 is a very good problem. See if you can do 28. This will be classwork number 2. Number 28. I'll give you about 4 minutes to do this because we're running out of time. Number 28.
We can't hear you.
Sorry about that. Anybody get 144 square inches as the decreased area between the large and the small square? So you got a big square, originally 20 inches on the side, would have an area of 400 square inches. You reduce the side length by 4 inches. You have a smaller square now that has a side of length of 16 inches, whose new area would be 256 square inches. To find the amount by which the area decreased, you would just subtract the new area from the original area and you would get 144 square inches. Anybody get that answer? So that would be your answer for number 28, classwork number 2. All right, ladies and gentlemen, that brings us to the last section here today, which is involving volume. That would be section 8.4. Volume, okay? Volume, unlike perimeter, which is a linear measurement, and unlike area, which is a square measurement, volume is a 3-dimensional measurement. So its units are cubic units, ladies and gentlemen, cubic units. So imagine this, if we have a box that measures 3 feet by 3 feet by 3 feet, maybe the length is 3 feet, by the width is 3 feet, by the height of the box is 3 feet. How many cubic feet of volume do we have contained in this box? Well, one way to determine that is to partition this box up into smaller little cubes. So if you take this side here, which measures 3 feet, and partition it up into 3 1-foot equal size sections, so 1 foot, 1 foot, 1 foot. Partition this side of 3 feet up into equal size 1-foot sections, 1 foot, 1 foot, 1 foot. Partition the height up into the same thing, 3 equal size 1-foot sections. You create little cubes. And how many little cubes, ladies and gentlemen, whose volume is 1 cubic feet do we count in this entire picture? So each of these cubes contains a volume of 1 cubic feet. So how many little cubes do we count? Well, how many levels do we have in this, like, kind of looks like Rubik's Cube, this entire picture. I don't know if you ever played around with that thing, but looks like we got 3 levels here, correct? And each level we count how many cubes? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 cubic feet of volume in each of these levels, but we have 3 levels. So what's 9 times 3? Well, that would give you totally 27 cubic feet of volume contained in this box that measures 3 feet by 3 feet by 3 feet. There's got to be an easier way. Instead of partitioning this box up into cubes and counting all the cubes, an easier way is this. To compute the volume of a box, it's nothing more than taking the product of the length times the width and times the height. So 3 feet times 3 feet times 3 feet gives you not 3 feet, not 27 feet, not 27 square feet, but 27 what kind of feet? Cubic feet, because feet times feet times feet, ladies and gentlemen, is cubic feet. All right. So here is the volume formula for any box. To compute the volume of a box, you take the length times the width times the height. How would you compute the volume of a circular based cylinder, better known as a can? Well, since the bottom or the top is in the form of a circle, we're going to have to compute the area of the circle and then multiply it by the 3rd dimension, which is the height or the depth of the can. So to find the area of a circle, it's pi r squared times the 3rd dimension of this 3-dimensional shape, this can, which is the height. That will crank out the volume of a can, okay? So pi times the radius of the circular top or bottom squared times the height gives you the volume of a can. How do you find the volume of a cone? This is a cone here. It's kind of like inverted, like an ice cream cone, but it's upside down. Well, the cone is characterized by a circular base that has a radius. And a cone is also characterized by a 3rd dimension, which gives you the height of the cone. The volume of a cone can be computed by using this formula, which is 1/3 times pi times r squared times the height. Now, you're probably wondering, where does the 1/3 come from? Well, that's a pretty deep question, ladies and gentlemen. To answer that question, you would probably have to do a little bit of calculus to demonstrate where the 1/3 comes from, okay? But this is not a course in calculus, and so we're just going to accept this formula and go with it. So therefore, the volume of this cone is going to be 1/3 times pi times r squared times height. How would you find the volume of a sphere? Our planet is in the form of a sphere, approximately. So is the moon, and so are other planets and other stars. Well, how do you find the volume of a ball or a sphere? Well, if you were to take a cross-sectional cut through a sphere, envision an orange, and you cut the orange in half. Do you agree that the cross-sectional cut is in the form of a circle? And where there's a circle, pi is not far behind. So ladies and gentlemen, the volume of a sphere is computed by using this formula. That takes 4/3 times pi times the radius cubed. Notice the radius of the sphere is the radius of the cross-sectional section of a sphere if you were to cut it in half, which is a circle. So it'd be radius times radius times radius times pi times 4/3. And again, don't worry about where the 4/3 comes from. You would have to use higher level math to demonstrate where that comes from. All right, so we're just basically going to go with the formulas and learn how to use them. Any questions about these formulas here? Let's compute volumes of various geometric shapes here. Okay. All right, let's just dive right in and start having some fun here. So what would be the volume of this box in problem number 1? How do you find the volume of a box? Well, it's length.
Length times width times height.
Yep, and since all these dimensions are the same, this box is a special type of box. It's called a cube. Do you agree? We have a cube that measures 4 centimeters on an edge. So to compute the volume of this cube, it would be 4 centimeters times 4 centimeters times 4 centimeters, which generates what? I believe that's 64 cubic what? Centimeters? Notice cubic centimeters now. We're talking about volume. So this is cubic centimeters. Perimeter are linear units like centimeters. Area is square units like square centimeters. Volume is cubic units, cubic centimeters. Okay. That's the volume of that box or that cube. And then in problem number, oh gosh, look at problem number 4, ladies and gentlemen. They want us to compute the volume of this shape, which kind of looks like a staircase. Do you agree? How are we in number 4 going to compute the volume of this entire shape? Well, first of all, let's see if I can draw that quickly on my paper so I can illustrate and demonstrate what's going on. Please bear with me here. Trying to draw this shape here. So I'm trying to draw it as accurately as possible. Let's see. All right, hold on. I'm trying to draw this here. If you want to draw it accurately, you really should be using a ruler. Otherwise, you're going to have slop. All right, let's see. We're almost done here. Okay, hold on. Oh, it takes a while to draw this picture. All right, I think I almost got it. All right, so I drew this picture, just got to get rid of a couple lines that don't belong. Okay, ladies and gentlemen, I think I did a, it's not perfect, but it's decent. Okay, see my picture there? All right, now what dimensions do we know? We know this measures 8 feet. We know that each of these dimensions measure 2 feet, 2 feet, 2 feet, everything's 2 feet. So 2 feet here, 2 feet here, 2 feet here, 2 feet here, 2 feet here. And we know that's 12 feet. All right, how are we going to compute the volume of this shape here? This is 12 feet here. Okay, so ladies and gentlemen, how do we compute the volume of this shape here? Well, do you agree that we could maybe partition this up into separate little, draw some construction lines in here, partition this up? Do you agree?
At the bottom step, there's 3 feet underneath it.
Let me see something. I missed something, didn't I? Hold on. Yeah, I see it. Thank you there. So this is 3 feet, very important here. So now look at, if this is 3 feet, then this would be what? 3 feet. This is 3 feet. This is 3 feet. This is 3 feet. This is 3 feet. And this would be what? 3 feet? You agree? Well, ladies and gentlemen, how many big old boxes do you see here if I draw these construction lines here? Do you see that we have 3 boxes? I got this box standing up, this tall one, we'll call it box 1. I got a less tall box, box 2, and then I got what? Box 3 here. Do you kind of see all the boxes? All we got to do is find the volume of each of these boxes and add them together. We got the volume of the whole shape. How do we find the volume of box number 1, the big box? Well, it's going to be length times width times height. So the length, we could maybe call it what? Well, we'll call it maybe 8 feet. Here to here is 8 feet. So we got 8 feet times the width, maybe call that 3 feet. Length times width times the height would be 2 feet. Oh, not 2 feet. Wait a minute. This is 2 feet. Wait, hold on, another construction line here. Couple more construction lines, so we can coordinate this off better here. Okay, look at, if this is 2 feet, this is 2 feet, this is 2 feet. What's the height of the entire box? Here to here. 2 feet plus 2 feet is 4 feet plus 2 feet is what? 6 feet? 6 feet tall. Therefore, the volume of big box number 1 is 8 times 3, which is 24, and 24 times 6. 144. So 144 cubic feet would be the volume of this big old box standing up. Volume of box number 2. Box number 2 is right here. And its dimensions are what? 3 feet. 3 feet times 2 feet plus 2 feet is this, which is 4 feet. 3 feet times 4 feet times what's this? 2 feet. Volume of box 2 is 3 times 4, which is 12 times 2 is 24. 24 cubic feet is the volume of box 2. Volume of box 3. Box 3 is a small little box down here. And what would it be? This is 3 feet. This is 2 feet. But what's this? Uh-oh. Well, look at, we know here to here is 2 feet. We know here to here is what? 8 feet. What's this going to be here to here? It's going to be 12 feet minus 8 feet minus 2 feet. So 12 feet minus 8 feet is 4 feet, minus 2 feet is 2 feet. That leaves us with 2 feet. Well, they told us this was 2 feet anyways. Okay, we didn't have to go through it. That's 2 feet anyways. All right, so what do we got here? We got the dimensions of the small box will be 3 feet times 2 feet times what? 2 feet? That's going to be 3 times 2 is 6 times 2 is 12 cubic feet. So what's the volume of this entire shape, the total volume? Well, that's going to be the sum of the volumes of the individual boxes. So that's going to be volume 1, which is 144 cubic feet. Added to volume 2, which is 24 cubic feet. Added to volume 3, which is 12 cubic feet. Oh, what's 144 plus 24? 168. What's 168 plus 12? 180. 180 cubic feet would be the volume of that entire staircase, ladies and gentlemen. That's the volume of the whole thing. Everybody see how we did that problem? Partitioned it up into three different boxes and added the volumes of the individuals together. All right, that's quite a problem. Just drawing that takes, does take some time. That's how you would do any of these other problems, by coordinating them off with some construction lines, and adding together volumes of individual boxes together. How do we find the volume of one of these cans here, like number 8? How many cubic yards of whatever you could put in here, sand or water or whatever you want to put in there? Well, how do we find the volume of a circular based can? Do we remember? Well, the volume of a can, if memory serves me correctly, I believe we have to find the volume of the circular base or top first. So that gives you their pi r squared portion of this formula, times the other dimension, which is the height, the depth. Okay, so pi r squared gives you this dimension, this 2-dimensional measurement, then times the 3rd dimension. So the volume of this can is going to be pi times the radius being 4 yards, so 4 yards squared, times the height is 8 yards. So the volume of this can is going to be 4 times 4 is 16, 16 times 8 is 128. So 128 pi cubic yards would be the exact volume. The approximate volume would be 128 times 3.14 cubic yards. And what's that going to give you approximately? What's 128 times 3.14? 401.902, 401.92, 401 and 92 of a cubic yard. There's the approximate volume of that can. That's the amount of whatever you could put in your liquid or powder of some sort or whatever. All right, problem number 14. To do this problem, you would have to find the what? To find the volume of this entire shape. Kind of looks like a nose cone of maybe a missile or something. How would you find the volume of this shape? Well, first you got to find the volume of this circular cylinder, this can, and then add it to the volume of this hemisphere. A hemisphere is half of a sphere, ladies and gentlemen. You get a hemisphere, okay? So how do you find the volume of that? Well, very carefully. So first you'd have to find the volume of the cylinder, or the cylinder. And the volume of the cylinder is going to be pi times the radius squared times the height. And then you have to find the volume of this hemisphere, which is half the volume of a sphere. The sphere volume being 4/3 times pi times the radius cubed. We're going to have to take half of that. All right, so what's the radius of this cylinder circular base? 6 feet, and the height is 3 feet. So the volume of that cylinder or can is going to be pi times the radius, which is 6 feet. That has to be squared times the height, which is 3 feet. So, ladies and gentlemen, we're going to find the volume of that cylinder first. 6 squared is 6 times 6 is 36. 36 times 3 is 108. So exact form, it's 108 rather, pi cubic feet. That'd be the area of the cylinder. That's the area of this, the cylinder. But then we got to find the area of this hemisphere here, which is half of what? Half a sphere. So how do you find the volume of a sphere? It's 4/3 times pi times the radius cubed, but we have to divide that by 2 because this is just a hemisphere. It's half of a sphere. It's like the dome of like a building, like a stadium or something. Okay. So what is the radius of that sphere? Well, the radius is 6 feet because that's also the radius of the circular top or bottom of the cylinder. So the radius of the sphere is 6 feet. Therefore, to find the volume of this hemisphere, we're going to have 4/3 times pi times 6 feet cubed, all divided by 2. Wow. What's that going to give you? 6 times 6 times 6 is 216. 216 divided by 3 is 72, and 72 divided by 2 is 36. 36 times 4. Oh, 4 times 36 is 144. So this is going to be an exact form. It's going to be 144 cubic feet. That's the volume of the hemisphere. So the total volume is going to be the sum of the volumes of the cylinder plus the hemisphere. That's to say 108. I'm missing pi here, am I not? Should be 144 pi cubic feet in exact form. So 108 pi cubic feet plus 144 pi cubic feet would be the total exact volume of that shape. And 108 plus 144 is 252. 252 pi cubic feet, ladies and gentlemen, would be the exact volume of that shape. Approximately, if you replace pi with 3.14, you get the approximate volume, which you have to get on your calculator and dial it up. What's 252 times 3.14? That gives us 791.28, 791 and 28/100 of a cubic foot approximate volume of the entire shape. Okay. All right, so that's the volume of that entire shape. That is problem number 14. Problem number 14. All right, how would you find the volume of this cone here? Number 16. Well, we have a formula for a volume of a cone. The volume of a cone is 1/3 times pi r squared times the height. Notice we have the height of this cone is a perpendicular drop to the circular base of the cone, whose radius measure is 1.1 inches and whose height is 3.4 inches. All we have to do to compute the volume of this cone is plug things into our formula. So the volume of this cone is going to be 1/3 times pi times the radius, which is 1.1 inches, squared times the height, which is 3.4 inches. You get on your calculator and dial this up, replacing pi with 3.14. You'll get an approximate volume. So if you dial that all up on your calculator, ladies, I'm going to see what we would get. So we'd have 1 divided by 3, that's 1/3 times 3.14 times 1.1 squared times 3.4, and I'm getting an approximate volume for this cone as being about 4.306, and that would be cubic inches. Okay. And there you go. That would be the approximate volume of that cone there. Any questions how we are computing volumes here using formulas for various geometric shapes? All right, I've worn out my welcome, ladies. I'm all out of time. Ooh, look at the volume of a pyramid. Did they give us the formula for the volume of a pyramid? Yeah, well, here it is. The volume of a pyramid is 1/3 times the area of the base. The area of the base is going to be just the area of a square. Notice the base of a pyramid is a square. So the area of a base is side times side. And then you'll multiply that by the height of the pyramid, h, times 1/3, you'll have the volume of the pyramid. Okay. All right. I'll let you just try one of those on your own. Okay, ladies and gentlemen, that is it for today. Ran out of time. We covered perimeters, areas, and volumes. And I will eventually get your quiz number 4 together. Right? And also the midterm exam. I will get that to you, and I will indicate the due dates for all those things. And also I will indicate precisely what I want you to send in as proof of having done homework set number 1. So just stay tuned on that very important email that's coming your way. If there are any other questions or comments, I'll stay on the line for a couple of minutes. Otherwise, have a great weekend, ladies and gentlemen.